as we define actually the big data and the enormous data to be processed, and systems have to deal with that in a matter of fraction of a second, like the search engine, the famous search engine Google, or any other software applications that deal with the enormous data. We here see a new innovation and new technology in question, which is the business intelligence. Still, we may talk about things similar to big data, and maybe the adoption of the big data in this field here, but with a new perspective and a new, let's say, goals defined behind the definition of this new technology, business intelligence. This scenario here actually replicates relevant technologies, but generally we are going to refer to a group of definitions, and most of them usually back-end solutions like the databases, and the purpose of the adoption of such decision-based system, decision-based and decision-enhancing system, and to automate this activity, how it is being automated. Enormous data being analyzed, stored and managed in background in databases, something like that, and then after the matter of the processing, it would help decision makers to make better decisions, and this is actually in an automated way and in an organized way, let's say. Something like that. So this is actually the main concern of this business intelligence. Case study, please refer to that. Please refer to this case study. Actually, it's the global mail system of the Toronto, something like that. Another case study. Originally, actually, all the data is being manipulated until the computer has come to existence. And even after the existence of the computer, the database management systems, especially, it was a scarce technology, because it was very aware about such technology to store and manipulate data in the background. Basically, means actually here the data was at the beginning of the early age was organized in a let's say structured way to find the historical, let's say, data somehow. Thus, all the data has to be actually recognized within a specific list of attributes, whether it is a paper-based process or it is a digital process. Every single data has to have actually a data storage in the database where all the data is being grouped. It has to have actually a sort of a linked resource, like the files, the portion of a file, something like that. And every single structured data, actually, it is being classified into lists of records and, let's say, values or attributes. Fields means no another text, no another way. And this design here we may see actually in action is a real case scenario where we see a sort of layers from down to top, byte, field, record, file, and another database. Those are 6 layers, but actually they summarize the main network layers. They summarize the main network layers, which are responsible for, let's say, presenting the historical data and historical, let's say, architecture, something like that. It starts from the file on top, from the resources themselves, the files or the resources themselves. The first conversion into an, let's say, real data, let's say, data, something like that, in char, string, and so on. And the other segregation into groups and extraction of the specific records we want, and this search term was red. Here it is. Then after actually, there would be actually different data types inside the database, and most of them be then, for example, most of them ints, chars, strings, flows, with different purposes. They are more inside the airplane, the aircraft. And actually, here we mean the database in general. But they are sorted somehow to see structured vision, structured vision. The use of the back-end solution generally, and specifically we talk about databases, it would ameliorate the data processing when we say an information system would help in making decisions. So such a system do not expect that we would actually make errors. It has to be accurate and very punctual. There will be issues that data recognize, and those issues that will be actually treated when we talk about the database and background. Redundancy, inconsistency, and being dependent to others, constraints, and let's say, yes, cascade constraints and so on. And it would give positive functionalities, actually, most of that, actually, capability to trespass the poor security, capability to give actually a higher resilience, flexibility, and it gives the chance to communicate actually channelly. Everything would be actually channelly connected. The chances to communicate, let's say, actually, to have resources and answer to different questions instantly, anytime, anywhere also. In traditional systems, it's a matter of segregation of roles within departments, and every single department needs to have an architectural, let's say, view. The head of the section, head of the department, something like that, and the rest of the members. It depends. It's a hierarchical review. This is what we see here in this scenario here, this graph. But later on, when we develop, actually, when we make the system gets into the work, we will be see actually things automated in an automated way. When I said that maybe you can lose some data, it is just a matter of means it depends on the case. Databases, it's not database management system. Database is the data store itself. Where we find the data is the place where the data owner, which is the resource, resides. Inside a database management system, we'll find a database. At the end of the day, the database management systems, DBMSs, they are a sort of a kind of, let's say, computer programs. They are interfaces, front-end interfaces, that are presented back hardware, back resources, to be utilized accordingly, more or less. Also, the context of the database would help us to segregate and separate the scenario of the logical approach and the physical approach. Amongst the issues solved when we develop the errors, we may find the redundancy, the consistency, the programs actually, let's say, and data which are not yet having a partner, something like that. So there would be actually having a solution here in the back-end management process. Kind of a relational database. We have a coordination between this system entity, database management system, the database attributes, and the separation of those attributes in between the users. More powerful databases, we might talk about the let's say, yes, the relational databases. Relational database management systems. It contains a list of databases, let's say something like that, but correlated all together. Or it's a one database that have a very correlated number of elements between each other. That's when we go for the relational database. Otherwise, we go for the NoSQL database, something like that. NoSQL database. Every single, let's say, attribute, generally it's the X7 and X4, has a group of properties or attributes also. A record is a tablet. It's just a sort of a record. Just directly here to avoid actually the talk. Every single entity inside the database would be represented with a list of values, and every single entity would have rows which are records. A profile of one student is one record. The ID of all students is the field ID. The ID of the student is a primary key, because a student would not have the same ID as his mother or something like that. So the ID is a key indicator to the entity. When we talk about the key entity, to the key field, we will talk about the primary key and foreign key. The key indicator for the entity in question is a primary key. And if you want to make a relationship in between this entity and another entity, the primary key from this entity will go to the next, let's say, entity as a foreign key, primary to foreign. An example view of, let's say, the relation database here, yeah, and we'll see how many details here. So here is the client number.